Hello guys, today we are going to be handling questions on differentiation, and today's questions are that we should find dy dx if y is equals to the square root of 1 plus 2x squared, all that power 5, and the B part says that given that y is equals to ln of 1 plus x squared divided by 1 minus x squared, we should show that dy dx is equals to 4x on 1 minus x power 4. So guys, stay with me as I'm going to show you the step-by-step process of handling such questions in differentiation. If you have not subscribed yet to my channel, don't forget to subscribe, like, share my videos, and comment on the comment section with questions you want us to make videos on. Without much ado, let's dive into the question proper. So as we said, today's question, the A part says that y is equals to the square root of 1 plus 2x squared, all that power 5. So the first thing we are going to do in this case is that we are going to make this question more comfortable for us by removing the square root. So as we know, we from indices, which we have a video on indices, how to convert such powers of square root. So from that video, we said that if we have a square root sign, that square root is the same as that thing raised to the power a half. So in this case, the square root of 1 plus 2x squared is the same as 1 plus 2x squared, all that to the power a half. If we eliminate this square root, the question becomes a little bit flexible. If you have not seen my video on the laws of indices and logarithm, go to my channel, it's Maths Time Questions and Answers, and you will see a video on that. So let's see, if we remove that square root, we are going to have y is equals to 1 plus 2x squared, all that power a half. But all of that is raised to the power 5. That's why we have times 5 there. So if we multiply a half times 5, it's going to give us 5 over 2. So that equation y is going to be transformed to y equals to 1 plus 2x, all that power squared, all of that power 5 on 2. Now we can differentiate this function easily. So the first part for us to proceed in differentiating this function is to let the 1 plus 2x squared to be any variable. Let's say p. So if we let p equals to 1 plus 2x squared, then we can differentiate x in terms of what? P. We can differentiate p in terms of x, sorry. So we can have the p on the x equals to, you know, when we are differentiating, we'll bring the power in front and then we reduce the power by 1. So the differential of a constant is 0. So the differential of 1 is 0. If we are differentiating 2x squared, we bring the power 2 in front and we reduce the power by 1. So if we bring the power 2 in front, we are going to have 2 into 2. One of the 2 is the 2 we have here, 2x squared. So we bring the 2 in front, 2 into 2 times x power 2 minus 1 would reduce the power by 1. So if we evaluate that, we are going to have 2 times 2 is 4 and 2 minus 1 is 1, and x to the power 1 is the same as x. So we are going to have the differential of p with respect to x will be 4x. So again, we know that y now will become, since we have said that p is equals to 1 plus 2x squared, then y will become p to the power 5 on 2. Okay, so if we have that, we are going to have y equals to p to the power 5 on 2. So we can differentiate y in terms of p. So dy dp will become dy dp, again will bring the 5 on the power of 5 on 2 in front, and then we'll reduce that power by 1. So we are going to have dy dp to be equals to 5 on 2 p to the power 5 on 2 minus 1. will reduce the power by 1, and 5 on 2 minus 1 is the same as 3 on 2. So the y on the p becomes 5 on 2 p to the power 3 on 2. Now we can get the y on the x because we know the y on the p and the p on the x. So to get the y on the x, we multiply the y on the p times the p on the x. With that in mind, we know that p is equals to 1 plus 2x squared. So we can replace that 1 plus 2x squared. We can replace p by that value. So the y on the p becomes 5 on 2 into 1 plus 2x squared, all of that to the power 3 on 2. Now we can get the value of the y on the x using the y on the p times the p on the x. So if we do that, we are going to have the y on the x equals to the y on the p times the p on the x. The p can cancel the p, so we'll end up by with the y on the x. So the y on the x will become the y on the p, which we know as 5 on 2 into 1 plus 2x squared, all of that power 3 on 2 times the p on the x, which we know as 4x. So we can evaluate. In this case, 2 will go into itself there 1 time, and 2 will go into 4 2 times. So we are going to multiply 2 times 5, which will give us 10 times x, 10x. So the y on the x will be 10x times all of this. So the y on the x will be equals to 10x into 1 plus 2x squared, all of that power 2 divided by 3 divided by 2. So we can change from here. If we want, we can change back the y on the x in the form of square root to contain square root. So in that form, we can have it as the y on the x equals to 10x into square root of 1 plus 2x squared, all of that power 3. So that's how we differentiate that y there. So the B section says that given that y is equals to ln of 1 plus x squared divided by 1 minus x squared, we should show that the y on the x is equals to 4x on 1 minus x power 4. So we'll differentiate y, and if we have 4 on 1 minus x power 4, then we have verified, we have proven. So again, y is equals to that. So to differentiate natural logarithm is simply 1 over the function attached to it, and if the function attached to it is differentiable, then we differentiate it as well. So in this case, the function attached to the natural logarithm ln is differentiable. So we are going to take 1 over that function times the differential of that function. So in this case, we are going to have the y on the x equals to 1 over that function, which is 1 over 1 plus x squared divided by 1 minus x squared times the differential of that function. To differentiate this function, some people equate the numerator to be u and the v, and then they try to differentiate them. But I've noticed from my past experience that it disturbs students. So I came up with what we call the bottom, the top, minus top, the bottom, all over bottom squared, where the bottom of this function is 1 minus x squared, and the top of this section is 1 plus x squared. So we are going to put the bottom here. This simply means we should differentiate the top minus the top, then we differentiate the bottom divided by the square of the bottom. So the y on the x in this case will be equals to 1 over that. Bottom will be there. Bottom is still fixed there. Bottom is 1 minus x squared. When we differentiate the top, we'll have what? The differential of a constant is 0. The differentiate x squared is 2x. That's why we have 2x there. Minus, we should keep the top and differentiate the bottom. So we'll keep the top, which is 1 plus x squared, into 1 minus x squared. So in this case, we differentiate minus x squared will give us minus 2x divided by the bottom, which is 1 minus x squared, all that squared. So if we have this, we have inverted this fraction here, because 1 divided by a fraction, we invert the fraction. So we have inverted, the denominator becomes the numerator and the numerator becomes the denominator. So if we open this bracket, we can evaluate. So opening up that bracket, we are going to have the function 1 times 2x will give us 2x minus x squared times 2x will give us minus 2x cubed, which we have there. Minus times minus will give us positive, so the signs here, all of them change to positive. And 2x times 1 will give us 2x. 2x times x squared will give us 2x cubed. So if we evaluate that, we are going to see that 2x plus 2x will give us 4x minus 2x cubed plus 2x cubed is the same as 2x cubed minus 2x cubed. So it will vanish. So we'll be left with 4x at the numerator. And then again, we can see that this function becomes 4x on 1 minus x squared divided all of that squared. So we can see that 1 minus x squared here is the same 1 minus x squared here, but all of this is squared. So one of this 1 minus x squared at the denominator here will cancel 1 minus x squared at the numerator here. So we are going to have that takes care of the squared there, and then we are going to open this bracket up at the numerator here, and 1 times 4x is 4x. So opening up this bracket at the denominator here, we are going to have 1 times 1, which is 1, and 1 times minus x squared is minus x squared. X squared times 1, which is x squared. X squared times minus x squared is minus x power 4. So the y on the x will now be in the form minus x squared plus x squared is the same as x squared minus x squared. It vanishes. So we'll be left with 1 minus x power 4 at the denominator. So the value of the y on the x will become 4x divided by 1 minus x squared, and that's what they asked us to show here. So we have proven that the differential of y, which is equals to ln of 1 plus x squared divided by 1 minus x squared, is the same as 4x divided by 1 minus x power 4. So guys, that's how we handle questions like this. Stay with me and don't forget to leave a photo of what is troubling you, and we are going to debug it for you. Bye bye.